And welcome to this topic on pneumatics for the Airbus A320 family. On this topic, we're going to have a division of this topic into two sessions, and that will be on session one will be on controlling the monitoring of the bleed air system, and session two is on the system components, locations, and their functions. So we'll also go over some of the operations, and the various components that are involved in different operations. So let's go ahead and get started on session one. As I mentioned before in the other sessions, in the other topics, you have, of course, computers. That's very heavily running things automatically. So we have the same thing here in the pneumatic system. There are two computers. These are the bleed air monitoring computers, and they are named BMC1 and BMC2, and that's one for each engine. So that leads me to mention what are the suppliers of the air. It's going to be coming from the engines, okay, and it'll be 5th stage and 9th stage air. Okay, so that's all from the high pressure compressor. So 5th stage and 9th stage. And of course, if for some reason, the BMCs are also going to control whether it's going to be coming or taking the 5th stage air or the 9th stage air into the user systems, depending on where the plane is, as far as if it's at idle, or if there's just not enough power, then it's going to draw from the 9th stage, okay, where you have a higher pressure than you have at 5th stage. So I just want to identify just quickly, and you guys have been around to know that we're going to have the pneumatics being supplied for the ice protection system. Okay, that's for the wings. So you have the wings ice protection system. Engine starting. Okay, so definitely for engine starting. The pressurizing of the hydraulic reservoirs, your water system, and also the nacelle anti-ice valve. Okay, that's the servo pressure. And so it's supplying air for that operation, as well, of course, as the air conditioning system. So we're going to get into air conditioning system in this module that goes along with the pneumatics, so that you understand that's one of the applications of the pneumatic power. So I mentioned about sources of bleed air, not only coming from both engines, but also from the APU load compressor module. So, and the nice thing about this, I don't know if you remember from some of the other GEM FAMs you might have taken, there were limits to the supplying of air from the APU at certain altitudes, and it depended too on whether or not we're talking about it providing enough air to supply electrical power along with helping with hydraulics. It just was a combination, and it just depended on that combination as to how much could be supplied at certain altitudes. Here with the APU, there can be the APU that the pilot can switch to on, that can give him what he needs at up to 20 to 25,000 feet. So that can be used definitely in the flight. And then of course, but mostly it's meant for any ground, if you're doing ground maintenance and you need that APU to be a power, you certainly have that as a ground air supply. All right, so what's the heart of this entire system? Are going to be the computers, like I mentioned before, the BMCs, which are your bleed air monitoring computers, and they're located on the 90 VU. Okay, that's in the avionics compartment. And what are they doing? What are we going to get into here with the bleed air supply system at all? Okay, we're obviously going to be dealing with valves, and we also want to make sure that there's the right pressure and temperature, that we don't have an over temperature, because we don't have an overheating issue and having it affect adjacent zones to the bleed air sources, where the engines are, because obviously we don't want to have a fire hazard. We don't want to have any serious damage to components. So it's going to be monitoring for those things, the valve positions, the temperature and pressure, and checking just for those conditions in adjacent zones to the engines and the APU area. There's also, it does a self-test, like a lot of these computers do. They just do a self-monitoring. And they also control the operation of the cross-bleed system. So I'll get a little bit more into the cross-bleed valve when we talk about components. And then there's also the bleed leak detection system. So it also, controls and monitors the bleed leak detection system. And so we'll definitely go into detail with all of that. So just a little bit more description on the bleed monitoring computers. You know where they're located, you know what their functions are, but in the way that they're, what's the input to these computers? Okay, we've got sensors, right? We have the temperature sensors and we have pressure transducers that are going to be sending those signals to the BMCs. Okay, and the BMCs are then going to send a signal to the SDACs. Okay, those are your system data acquisition computers. And then once it goes through there, then that information from there is sent to the Ecam page. Okay, it's to the Ecam bleed page specifically. So that's what those computers are doing. They're gathering that data, gathering those discrete inputs, and then eventually, all that's going to the Ecam page. And those are what you're going to see there on the Ecam. We're going to get into that. But we're looking for over temperature, over pressure, and valve position, and also any leaks, because that's what the bleed leak detection system's job is to detect if there's a leak or a burst. And then what it's going to do is going to stop that air supply, when there's a fault like that. So the BMC signals directly to the air conditioning overhead panel. That's the 30 VU. And it's going to send those signals to the engine. There's an engine 1 button and an engine 2 button. And those are going to have, if there's a fault, then it's going to show that there's a fault on that. So, so you have that. And then the BMCs are also going to control the closing of the pressure regulating valve, or reducing valve, during the engine start, APU bleed, and that's automatic mode. Also of the cross bleed valve, and also the APU bleed valve. And those are opening, so for opening. They're going to monitor the correct operation of the entire system, essentially, and then sending all that to the maintenance computer. Okay, that's your CFDS, your centralized fault display system. Okay, so for those computers are very important. Obviously, they need to be, maintained, because they're doing a big job of, sending out information to the Ecam, and that Ecam is what the pilots are relying on to be correct information. Okay, and we've had cases where you guys know pilots have actually looked at readings on the overhead panel, or looking at the readings there, and turns out that some of those cases the reading was wrong, so they were then of course reacting to that, and then ended up crashing. So very important chain of events here with all of that. Okay, and you get a feel for kind of the avionics compartment and where the BMCs are located. Okay. All right. So it gives you an idea with the bleed air monitoring system, computers, and what they're responsible for. So let's kind of get out of the avionics compartment for a minute, and let's just kind of head over to inside the flight compartment. Okay, at the panels. So let's just look at see what kind of switches we had. I know I mentioned the engine 1 and engine 2. So what you have on there, you do have an engine 1 bleed push button switch. You also have an engine 2 bleed push button switch. Each of those has the word fault or off. The fault will show up in an amber color. And you also have a ram air button, but you also have your APU bleed. Okay, so you have all those. You have those 3 buttons there. Now, for your engine 1 and 2 bleed, when you have it on, okay, the bleed valve is open, but it also could be closed. It just depends on what the selection is for the cross bleed selector, and also for the APU bleed switch. All right, and then of course a fault light's going to come on in amber on that push button switch that's associated with the Ecam caution. Okay, that's Ecam bleed page, of course, along with the master caution light, and also there's an aural warning. So there's going to be an auditory sound. There's going to be a sound going on when there's a fault, and that's going to happen when. Okay, remember what I mentioned. It's going to be either pressure related, temperature related, or you're going to have an overheat. Okay, so temperature is going to be over temperature that's downstream of the precooler. Well, I'll get into the components in a little bit, but I'm just explaining to you and describing that there's two push buttons on the panel, engine 1, engine 2 bleed, and then that there's a fault light that could come on when there's a fault, obviously. So if there's a pylon wing either on the right hand or left hand, and there's an overheat detection, then that fault light's going to come on in amber. If the engine 1 and 2 PRV is not automatically fully closed during the start, engine starts, then that fault light's going to be on. And remember, over temperature downstream of the precooler, and it's also going to show up in amber. And position for the switches of being off is going to be the button's going to be out. Okay, versus if you put it, it's going to be in. Okay, your bleed valves, those are closed. When the switch is on off. Now, what about the APU bleed switch? Okay, when the bleed switch is on, then the APU bleed valve is open. We're assuming that there's enough RPMs. Okay, so the end's going to be greater than 95%. And also the on light comes on blue, associated with the Ecam, and the engine valves are closed, and then you have a cross bleed valve that's open if it's in the auto position. Okay, now your cross bleed selector, because there's a cross bleed system. Now the cross bleed selector has, you have your auto position, and you have your open, and you have what's called shut. So if it's say the valve is in the shut position, then the motor 2 closes that cross bleed valve. Okay, and then on the bleed page of the SD, there's going to be a green cross bleed valve symbol that shows in the closed position. So closed, you're going to see it in green. Okay, when it's in a shut position. If it's an open, then the motor 2 opens the cross bleed valve. Okay, shut, obviously closing the cross bleed valve. And then open, well, it's opening the cross bleed valve. Okay, and that's going to show, it's going to be green, but it's going to show in the open position on the little picture. Okay, and that's going to be, when it's in an open position, that can only be the case when you have at the start of an engine with the bleed air from an engine on the other wing, okay, but not during flight, or the start of the right engine on the ground through the ground connectors, okay, or with the bleed air supply coming from the APU. So that's another condition. The cross supply of the air conditioning packs. Okay, so those are the times that you want to use the cross bleed. All right, so that gives you an idea of the switches. Again, this is strictly pneumatic control switches. Obviously, there's, we talked about the hide page for hydraulics. Here we're talking about the bleed page for pneumatics. Okay, so and the diagram shows you just basically, they're just push buttons, for engine 1, engine 2, and the APU. Okay. All right, now what kind of things could you possibly see on the Ecam bleed page? Okay, what's going to come up there? Well, you've got different things. You're going to be looking at the bleed valve, the APU bleed valve, your engine, and of course your engine bleed valves. The engine high pressure bleed valve, your engine number, the precooler outlet temperature, and your inlet pressure. So inlet pressure on the precooler and outlet temperature on the precooler. Okay, we're talking about engine precooler. So those are indications there. And there's a certain threshold on pressure. We're talking about the precooler inlet pressure. That needs to be, at a certain PSI. If it goes below 4 PSI, or if there happens to be an overpressure, then there's going to be a display in amber. Okay, that's going to be the precooler inlet pressure. is going to be displayed in amber when that occurs. And of course that's going to the S stack. Okay, now if for some reason the pressure is not available to or from the S stack, then instead of, it's going to actually show an amber XX, okay, instead of the inch precooler inlet pressure. And then the pressure value can be, there's a range of it, can be from 0 to 98 psi in steps of 2, so that's just this range to display, what psi it is. And then you also have the engine number. This is the engine number. That's normally shown in white. If it's displayed in amber, then that means the DMC is receiving from the engine buses the signal, engine below idle. That's when you'll see that. The engine bleed valve on this, that indicates, the pressure regulating valve. It indicates the position of that regulating valve. Because remember I said that we're going to talk, the BMCs are responsible for monitoring the valve positions, and all that information is going to be going through the S-stack to the Ecam bleed page, which is what we're talking about right now. So, with here, the ENG bleed valve is indicating the position of the pressure regulating valve. And that's based on the air delivery form, from the IP, so we're talking about the 5th stage or the 9th stage air. So with valve indication on the Ecam page, it can be green. It's green and open when the bleed valve is normally not fully closed, or green and closed when the bleed valve is normally fully closed, and the related engine is running. Okay, it could be showing amber and open when the bleed valve is not fully closed and there's an engine pressure regulating valve that's disagreeing from the BMC through the S-stack. Okay, and if you see the XX in amber, the bleed valve position is just not available. Okay, anytime you see white indication, that is going to be the intermediate pressure IP indication. That's 5th stage error. Okay, and the diagram gives you an idea where things are located there, and you can see the circles with the lines there showing your IP, your HP. Your IP is your 5th, HP is your 9th, and also showing your pressure regulating valve. Okay, and your high pressure valve as well. Okay, engine number, so you got engine number 1, engine number 2 on the right on the Ecam bleed page. Okay, and also shows your sat and your tat and sat at the bottom, but it's going to give you an orientation of what it looks like. All right, so also the cross-feed valve, because you have cross-feed valves, cross-bleed, same thing, but valve open in green. Okay, that's when the valve is open as it's has at its input, and there's no faults, that are indicated at all. So valve open in green, the valve is open as commanded, and there's no faults. The valve closed in green, and that's when the valve is fully closed. If it's closed and amber, then the valve's fully closed and there's a manual or an automatic command to open, and there's a closure disagreement. Okay, so amber is always a disagreement. Okay, green means there's not. Everything is good. Okay, your AP valve operates, shows or indicates similarly. The valve is open green. All the cases, are not valid. The valve is closed in green when the APU valve is fully closed. All right, remember that amber XX. That just means when there's not the information available. In that case, I'm just talking about the crossfeed and the APU valve. The APU valve, when you see the amber XX, is just saying that it's not valid information transmitted by the S-stack. Okay, so switches. It's pretty straightforward. Just remember, switches are located on the 30 VU in the flight compartment. And then we have the Ecam bleed page and the different things that could be listed there. Talking about the Precooler, inlet pressure and outlet temperature. The engine numbers will be on there. Your engine bleed valve, and of course your APU bleed valve, as well as your crossfeed valve. Okay, on the engine bleed page. Okay. All right, so that gives you an idea with knowing about the BMCs, your BMC1, BMC2, and then you have of course the push button switches in the flight compartment. Your BMCs just quickly are located in the avionics department on 90 VU. That may be a test question, so just jot that down. Where are those BMCs located in the avionics compartment? Where are they located? Okay, it's 90 VU in there because you got 80 also. All right, so what else does the BMCs control? Okay, what else are they monitoring? We have a bleed leak detection system, and this is going to be detecting not just for leaks but also for bursts that might occur. And when that happens, a leak is dangerous, a burst is definitely dangerous to be affecting the rest of causing damage to other components. So you don't want to have a continual flow of air going in through those ducts. So the leak detection system, okay, has different loops. These are just detection loops, if you're familiar with that at all, or some of you haven't, because I know some of you guys are just strictly structures, and maybe you haven't maybe been a line mechanic, because there's a lot that can you guys can get exposed to versus being kind of in the hangar. But and again, I know but that's what this is. These are actual detection loops that make up the detection system, and there's 7 of them. Okay, and those are, those monitors are going to be monitoring, those computers are going to be monitoring those detection loops. You've got the detection loops running through the wings, so you can kind of see the diagram and where it's going. You have loops A and B. You got your right hand wing, your left hand and right hand pylon loops, and fuselage APU loop. Okay, so you've got those there for, essentially they're sensing any overheat that's going on in those areas. All right, and just know they're located, you see the diagram, but they're located in the APU. You've got, obviously, in the engine pylons, the wings, and also the belly fairing is where they're at. They're installed in each wing. And there's clamps and your rubber grommets that are attached to the overheat sensing elements along the whole length, and that's in the part talk about the. And then you also have in the fuselage, so those are installed and they're close to the bleed air duct, and then they continue up to the check valve on the fuselage. Okay. Okay, and then you've got, also the ones for the pylons. So these sensing elements, okay, the sensing elements are monitoring the areas for wet, obviously for too much heat. If there's a heat up, then it's going to be, sending that information, or that information will be picked up by the BMCs. Okay, so what's going to happen is, like I mentioned before, is it doesn't want to continue having that bleed air supply. It wants to shut it off, and that's what it does. And just kind of a thing on the loops A and B, and this is a standard, because if you recall from other Gen FAMs, but you have that loops A and B. If one of them is not working, then the other one's going to just take over in sensing. Okay. All right, so, and of course, just a little description of it. These are pretty standard material as far as these sensing elements. Eutectic salt, fills the tubing in it, and has a mixture in there in order to just because of the conductivity of it, to be able to detect. So that's what that is. The wing, as far as our thresholds and a temperature that's too much, it's going to start you know, sending signals at 124 plus or minus 7 degrees Celsius. Okay, and on the pylon side, that's at 12 degrees Celsius. So those are your threshold temperatures that's like, okay, that's getting too high, and so that's when it's going to start sending those signals. All right, and just kind of a tip here. Let's say a leak is detected, then that leak will close associated valves. Okay, it makes sense. And those valves are automatically controlled to close if they were open. Okay. And just remember, the APU and the cross-feed valves or cross-bleed valves, either way, do not close during main engine starts. Your MESs. Also, with engine 1, you can have the engine 1, engine 2 faults, but there's going to be a slight difference with this. So let's say you have an engine 1 fault. Okay, it's going to be the pylon. At the pylon, you're going to have a leak, or let's say the left-hand wing. Then which valves are going to close? Okay, question. So if there's a fault showing on engine 1, then you're going to have the closing of the APU valve, the crossfeed valve in an auto position, the anti-ice valve 1, and the PRV 1. Okay, if we have an engine 2 fault, then you're going to have the closing of the PRV, anti-ice, and cross-bleed. Okay, but not the APU. And then during APU leak, let's say that there's a leak there, then the APU bleed valve is going to close, as well as the cross-bleed valve. Okay. All right. So what happens is all this information has got to go somewhere, right? The signals are being picked up. I mentioned about the BMCs are going to be sending signals to the Ecam system because, right, the pilots need to know what's going on. So those signals are going to, trigger an amber fault light on the air conditioning overhead panel. Okay, that's your 30 VU. And the activation of the Ecam. So Ecam's going to be going off and showing things. We got the master caution lights that are going to come on, panels 131 and 130. There's going to be a sound that's going to go off. And you've got your message on the upper Ecam. Okay, that's also where it usually displays what kind of fault it is. Your bleed page on the lower Ecam display unit, that one comes on. So normally it's off, but if there's a fault that's going on, or gets triggered, then you're going to have that bleed page actually show on the lower Ecam part. Okay, and it's going to continue. I mean, that overheat condition, as long as it's there, then the fault's going to be there. If somehow there's a relief of that heat, then the fault light's it's not going to be illuminated. Okay, so if it does, let's just say that it gets relieved, then you're going to have the circuit's going to have to be reset to open the valves. Otherwise, they're just going to be closed. That was what it had been doing before because the fault was found. So, all right. So you got the fault legend on the engine 1 and also the engine 2 and the APU bleed push button switches. And those are going to come on if there's that overheat condition. Okay. All right. Okay, so kind of gives you an idea on, what the chain of events is, like what happens, when you have a fault, when you have an overheat, valves are going to start closing. Okay. So remember I mentioned about the transducers. You do have 2 pressure transducers that are monitoring the air pressure available in the circuit. Okay, and so the BMCs are monitoring the electrical signals from micro switches, also of the valves, also the temperature at the precooler outlet. Okay, and the transferred and the regulated pressures. Okay. All right, so that kind of gives you an idea. We do know, again, just, the faults, fault lights are going to come on. We do have those on the engine 1, engine 2 bleed push button switches. And then, what's going to show on the lower Ecam display part, that's going to be your bleed page. It's going to come on when those faults come on. And those faults are detected. Okay. Also, while I'm on this, since we're talking about monitoring and controlling, and this is session 1, I'm going to go and throw in on troubleshooting, because when these things are detected, monitoring means they're monitoring, right, for any faults, making sure there's not. If there is, it's going to send that information to the Ecam. Is also the centralized fault display system. So your CFDS, is going to be there, receiving information, and that way maintenance, you guys can know, right, what's going on. So with the CFDS, okay, that's going to get the information from the BMCs. Okay, BMC 1 or BMC 2, and then your MICDO, okay, in the cockpit is going to display that information, just so you know what's going on. So we have similar reports as I mentioned before, in other, with other topics, but here we got last leg, your previous legs, your LRU identification or ident, your current data, and your class 3 faults, okay, and your test. So this is for maintenance. And you can see kind of an idea on the picture, what it looks like, just how it's displayed essentially, it's all. Okay, your LRU identification, it's just displaying the manufacturer's part number for the BMC. Okay, and then you can run a bite test of the BMC by just hitting the test, okay, and that'll run it. And remember what I said, the BMC is so important to make sure it's running, because if it's picking up the signals from your pressure transducers and temperature sensors and all, if it's not working properly, if there's something not working there, then what's going to happen? Garbage in, garbage out. But garbage in was fine, but then once it got through that BMC, there could be wrong signal, whatever, sent to eventually this S-stack and eventually the Ecam. So it's important that it's maintained. And doing these tests are really making sure that the BMC is running correctly. Okay, basically for its own self. And then the aircraft reports I mentioned before, last leg, previous legs, etc. There's bleed status. That's indicated with coded information and also your numerical values. So 0, for example, is indicating that the valve is closed. 1 is going to indicate that it's open. Okay. All right, so that gives you an idea. It's good to see the pictures just to give you an orientation on display, compared to other aircraft. But for the most part, I mean, it's pretty self-explanatory. We know when it shows up. Okay, last leg report. You know what that is, and previous legs report. Your LRU identification, current data, your class 3 faults. Okay, so it's pretty standard there. And then of course your bleed leak detection system's important. Making sure that there are no leaks, or detecting those leaks, and then shutting off that air supply when that's detected. And then of course what it looks like in the on the Ecam bleed page, and we're also right on the push button switches with the amber amber color showing up there, so you have the fault illuminated. Okay, and then your sensors, I'm going to talk about the detection loops. They're running through the wings, your pylons, your belly fairing, and the fuselage, and the APU area. All right. Okay, so this concludes session 1. And we'll get into the components because there's a list of them. Your components mostly are valves and So, you know, how they operate and how they relate, you know, how they relate to the other components. We'll kind of give a little, actually I'll go ahead and provide a kind of a flowing of it, like a flow chart of it, but mainly it's identification of the parts themselves, you know, knowing what these valves look like. Okay, so, and also transducers, because I know I just mentioned about the loops for overheat detection. Those are your sensing elements, but, you know, what about the pressure? So those are part of your components as well. All right, so, and we will get into session 2. We will have knowledge checks, so I'll just kind of give you a review of this session 1 that we just went through. You know, we're going to start going over questions like we do with the other ones. All right, so we'll go ahead and move on to our knowledge checks and then session 2. We are now on to session 2, and this is identification of the components, the functions and locations of the pneumatics system. So I'm going to go ahead and start with the bleed air Precooler exchanger. So, and then related parts to the exchanger. You have an exchanger, and that is just cooling. Obviously, it says Precooler, so you know it's cooling that hot air that's coming from the engine compressors. And there's going to be some monitoring of that with certain other components. But that's what it's for. It's basically exchanging the heat so that it's cooling that air coming from there. The Precooler exchanger, along with the fan air valve and the thermostat, the fan air valve controlled thermostat, and obviously the outlet temperature sensor for the Precooler exchanger, all of that is located, with the exception of the sensor, but the parts I just mentioned, the fan air valve and thermostat, are located in the engine pylon. That's where you'll find the bleed air Precooler exchanger as well. So all that's in the engine pylon. And the outlet temperature, and I'm talking about the Precooler exchanger outlet temperature sensor, there's a sensor in the wing leading edge that's aft of that engine pylon. So you'll find that there. Okay, so, but that's what its primary job is. It's just to cool that really hot air coming through. And since I'm getting ahead a little bit, but you can just know that key degrees of Fahrenheit there is 392 degrees Fahrenheit or 200 degrees Celsius. But just so you know, it's trying to monitor to keep it at a certain temperature and not be too hot. And basically the Precooler exchanger is a box. You've got an outlet flange, you have the inlet and outlet, to get the inlet box, which is where the hot air goes in, and then the cooling air from the fan. Okay, and you can kind of see that broken out. Okay, all right, so then the fan air valve. There's a fan air valve. It is downstream of the Precooler exchanger, and that fan air valve is, its purpose is to basically regulate that temperature of the air. Okay, so that's what it's doing. Okay, and then you remember I mentioned that 392 degrees is going to be, basically monitoring that to make sure it's around that degrees Fahrenheit. And then you also have some safety devices involved here with the fan air valve. It has a test port, and that's enabling to just have a test of that. There's also a manual override that can close the valve mechanically on the ground, just so you know. Okay, all right, and then there's also, and you can see kind of the position of things where the test port's located, the cover plate, and then you have the electrical connector. Okay, and then your butterfly, there's a butterfly style valve, and then the actuator assembly is part of that, that whole fan air valve. Okay, you also have that thermostat. It is called the fan air valve control thermostat, but it can also be called the temperature control thermostat. So it's called, if you see TCT, that's for temperature controlled thermostat. That's the fan air valve controlled thermostat. And of course that's downstream. That's going to control the engine fan cooling airflow in order to maintain, remember what I said before, that 392 degrees Fahrenheit. Okay, and of course, if the temperature, downstream goes below the required value, then certain things are going to happen. You got the valve that's going to remain closed, no air flows through the pressure regulator, and you've got the invar rod valve that's just going to remain, remain in its position. Okay. All right. So, and just kind of a little bit of a tip, if you will. There's a nut plate retainers, and those nut plate retainers are not physically attached to the mounting frame, so basically just be careful because they're not attached. And if you are trying to remove things, then you're going to have that retainer that could possibly fall into the pylon cavity and mess some things up, so don't want to have that happen. Okay, you're going to kind of see a picture of how what the thermostat looks like. We've seen thermostats before, so it's they're similar in design as far as it relates to aircraft in particular. You've got an attachment plate, you've got the valve itself, the filter, and you have also a tube that makes up that thermostat. Now, as all part of and related to the air that goes through the precooler exchanger, you also there's also a monitoring of the outlet temperature from that exchanger. And so there's a sensor that's located in the wing leading edge that's aft of the engine pylon, because all the other components are located in the engine pylon, except this temperature sensor is located in the wing leading edge. Okay, and so that's just so you know where that's located if you come across that. All right. Okay, so that kind of gives you an idea with what's involved, just along with that precooler exchanger. Okay, and then we also have the transducers, because remember I said there's temperature sensors, so we just talked about one right now, right? We just went over that, but also the transducers. So what transducers do we have? Okay, there are two of them. There's a bleed transfer pressure transducer, and there's also the bleed regulated pressure transducer. Okay, so there's two transducers, and they're installed on a bracket in each of the pylons. Okay, so let's kind of just start with the describing one of them. This is the bleed transfer pressure transducer. It's important I started with this besides the cooler, because the transducers are the ones sending those signals to the BMCs, right? So where's it going to start? Where's the input coming from? It's coming from the transducers as far as pressure. So those are going to be sent to the BMC. Okay, those are going to be sent then to the SDAX. It goes to the Ecam bleed page. Okay, that's the chain, it's the chain of events as far as the input, output, that type of thing, going straight to where the pilot can know what's going on. So with the transfer pressure transducer, it's going to be monitoring the pressure of the engine bleed air. Okay, and it's giving the static pressure downstream of the high pressure valve, and it's also used to measure the transferred pressure, which is the pressure between the bleed pressure regulator valve and the HP bleed valve. Okay, so now we know why it's called a transfer pressure transducer, because we're talking about transferred pressure between the regulator valve and the HP bleed valve. Okay, so that's what you have there. The transducers themselves, if they can kind of see the diagram, kind of how things are broken out, or what different little pieces that you have, parts that you want to be aware of. I mean, you've got plates, and you have a silicide plate. Okay, there's a measure shell in there that contains this silicide plate. That's part of a resistance bridge, what they call the Wheatstone bridge. So you have that as part of the transducer. Okay, the attachment plate that you have has 3 holes so that you can install the transducer on the bracket. So you can see that kind of exploded out in the picture. And as far as its power source, the pressure transducers are getting it from a bus, okay, the ESS bus. Okay, and there's also another one from the normal bus. that's for engine 2. All right. Okay, and like I was saying before, remember that train, it goes from transducers to the BMCs to then the SDACs and then eventually to the Ecam bleed page. Okay, it's going to show there. And of course, we know that if there's going to be the pressure's too high, then what's going to happen on the Ecam bleed page is going to indicate a color. Okay, the color is going to be what? Amber. Amber's the color for caution, something's not right. So that's what it's going to show. If everything's fine and it's just displaying, that pressure, okay, that's not that there's no other indication of it being outside of range, then it's going to be in green. Okay. So let's just kind of think about the pressure transducer. It's monitoring the pressure. Don't want to have an overpressure, and it's sending this information eventually that gets to the Ecam bleed page. It's also going to give the high pressure valve fault Ecam warning if the transferred pressure. Okay, so now here, if the transferred pressure is less than 23 psi during more than 15 seconds, and also if the HP bleed valve is fully closed. Okay, so it will give that warning based on the pressure, okay, transferred pressure. And then the other instance is to give the air ing abnormal press Ecam warning. So basically it's letting the pilot know, okay, there's something wrong. It's the pressure's not where it should be. Okay, and then so we have that's the transferred part, and then there's also the you've got a bleed regulated pressure valve, okay, and the bleed regulated pressure valve or pressure transducer, okay. We have this one, and it's also monitoring the pressure of the engine bleed air. So here's similar design, transducer as far as that goes, but you have that one as well. It's just regulating the pressure. Okay, the other one was talking about a transferred pressure between two valves. Here, this is just monitoring the pressure of the engine bleed air. Okay. And there's an additional, on this particular one, there's an additional function, and as far as indications are, showing on the display, is it's going to give a wing anti-ice fault on the Ecam. So that you don't have that on the other one with the with the pressure transducer for transfer, bleed transfer, but bleed regulated pressure transducer will give a wing anti-ice in-op Ecam status on there if there's, again, there's a, out of range pressure. Okay. All right, so those are the two. So if you're ever questioned on a test, what are the two types of transducers? We're talking about pressure transducers because transducers have to do with pressure. Then you'll be able to name them. It's the bleed transfer and the bleed regulated. That's the answer. Okay. All right, and we have to have a pressure regulating valve, of course. So we have pressure regulating because we don't want to have an overpressure, but in case that we do have an overpressure bleed valve for that particular event. So with here, the pressure regulating valve is located on the engine at the 1130 position. Okay, it's a butterfly type valve, spring loaded, closed in absence of upstream pressure. So just pretty standard. The minimum upstream pressure, you have a minimum upstream which is at 8 psi-G in order to open up that valve. Okay. Now, when does it close? When does the pressure regulating valve close? Okay, remember it's regulating the temperature. We want to make sure there's not an too much temperature, it's not too high. So it's going to close if there's an over temperature downstream. Remember, we were talking about I mentioned about the Precooler exchanger earlier, and you know, just the cooling, right? Using the fan air valve and the thermostats there to monitor that. So here at 257 degrees Celsius, okay, so that's when it's going to close. That's when the pressure regulating valve is going to close. If there's an overpressure downstream, okay, of the pressure regulating valve, and that overpressure is at 57, give or take, 57 psig. The other instance where it may not close, or excuse me, where it will close, is if the starter valve is not closed. Okay, so if that's not closed, then it's not going to close. Okay, and any sensing of overheat, then that pressure regulating valve is going to close. Okay, and that could be overheat in the wing, the wings, it could be the fuselage, okay, places like that, or any of the adjacent zones. All right, so it's controlled also to the closed position by crew. When you have an engine fire or engine bleed, when those are activated, those push button switches are activated, then you're going to have the PRV. It's going to be in the closed position. Okay. All right, so that's what it's doing, is regulating, you know, regulating that temperature. Okay, and just regulating the pressure. Okay. Okay, it's a pressure regulator, right? Okay, so, and just kind of gives you an idea what I mean. Of course, with valves and whatnot, you've got your actuator assembly. Again, basic components of a valve that you have to have, no matter what. Okay, so that's the pressure regulating valve. Now, I'm going to get into now talking about or describing the intermediate pressure check valve, okay, because that should be sufficient. But if for some reason, or which we're going to have anyway, in cases where aircraft is constantly changing, right? So it's at idle, you know, it just doesn't have it's cruising, and there's not, you know, enough power necessary at that time. But the demand for the user systems is there. Then what? You know, it's going to have to pull from the high bleed, okay, from the 9th stage of the high pressure compressor. Okay, so that's what we have. And so in the intermediate pressure check valve, let's just go over this one. The IPC, okay, if you see IPC, that's intermediate, okay, pressure check valve. This is going to prevent reverse airflow, right? That's what check valves do. They allow the air to go one direction, but not to have it backflow, if you will. And that's because, you know, it prevents that airflow when you have a high pressure 9th stage that's coming into the pneumatic supply, okay, during the power point low thrust operation. So it's going to allow high pressure to take over. Okay, so, and that part is installed in the duct that's leading from the 5th stage of the high pressure compressor in the engine compartment. Okay, that's actually at the 9 o'clock position. So where is the intermediate pressure check valve located? It's at the 9 o'clock in the engine compartment. That's the answer. Okay. And then this is a butterfly style. You've got your flapper. You've got your, as far as the design of the valve hinge pin, that kind of thing. Okay, so that's the intermediate pressure check valve. Now we're going to go to talking about the high pressure bleed valve. Okay, this is for the, you know, high pressure bleed valve, the valve for, you know, the air that's coming from 9th stage. So here you have the high pressure bleed valve that opens in order to allow that high pressure to supply the pneumatic system, the bleed air, you know, to the user systems. And it's going to be doing that. Remember what I said, if for some reason that, because everything should be at first coming from the intermediate bleed air from basically the 5th stage. So that's the intermediate pressure to supply that power to the user systems. But if there's not enough engine power because it's not necessary, depending on where the aircraft is, if it's just idling either on the ground or even up in the air, it's not going at full thrust, then it's gonna, that power is gonna come from somewhere else. That's coming from the 9th stage. So that's when you have the high pressure bleed valve that's gonna come in. And this is a butterfly type valve as well. It's gonna shut off and act, as both a shut off and also a pressure regulating type of operation. The minimum pressure is 8 psig. That is necessary in order to open up the valve. Okay, and that's going to limit that static pressure. Okay, you got static and dynamic pressure. Here we're talking about static pressure. It's going to limit it to a certain number of psi, and that's going to be it's going to be 36, roughly 36 psig. Okay, and then it's going to close fully pneumatically when the upstream static pressure reaches 120 psig, give or take. Okay, so just so you know the triggers, high pressure bleed valve limits the downstream static pressure to 36 psi. Okay, and then it closes fully pneumatically when that pressure reaches 120. All right. Okay, and the picture just kind of gives you more of a feel for what the components are for this one in particular versus other valves. But you always have an electrical connector, actuator assembly, etc., a cover plate. It's a butterfly style, right, of valve. Okay. This is located also in the 9 o'clock. So your high pressure bleed valve, high pressure bleed valve is at the 9 o'clock position. Okay, same as where your IPC is. Okay, and that's roughly where that's at. Okay, so that's what you have is the high pressure bleed valve for that. There's also a bleed override solenoid, and override, okay, is for what? We're having venting off of some of the air. So it vents off some of that high pressure bleed valve air pressure during the cruise flight. And that's just to prevent the HPV, the high pressure bleed valve, from opening when there's low cruise thrust. Okay, and that's when there's that, I remember I said when there's IP, which is not sufficient, let's say at that moment where the demand is still high or still up there for those user systems. Okay, that one is actually located in the engine pylon, because remember I mentioned the precooler again? Precooler, heat exchanger, all that, and the fan air valve is located in the engine pylon. Well, guess what? The bleed override solenoid is also located in the engine pylon. Okay, and that's going to be in the area after the heat exchanger. Okay, it's on a bracket in there. Okay, and then you have, of course, that connecting to the HPV PRV coupling sense line. Okay, because it's going to be having to do with the high pressure bleed valve is going to be connected, right? So that's where that is in relation to the other, couple of the two components there. All right, so you have this okay, so you have this particular solenoid that is energized by the BMC, okay, the computers, and it opens to the ambient HPV PRV coupling sense line, which lets the HPV controlled close pneumatically. Okay, just allowing that to close pneumatically. Okay. And then just a caveat, I should say, obviously these things have my little miniature part, I should say multiple parts to it. So, just be very diligent, obviously. I mean, when you're working on these things, because just when because I know in some things in the past, the models where in some cases they were apart, and then some of them they're not. They're actually attached, where it's not something you can actually remove and replace that part. So, and it also depends on the model of aircraft as far as how, what's installed in that particular aircraft as to whether something's mounted permanently or something that can actually be removed. So kind of be aware of that. That's just kind of a reality that's definitely, you know, applicable here when I'm talking about these engine bleed air components. So just heightened alert, okay, on that. Just things may not be attached. Be careful with when you undo something, because you may be, you know, a couple of things may drop from that. So we just want to make sure that we're very diligent with all of that. Okay. All right. So okay. So that's covers the solenoid. Okay, and you know, we also have. Remember I mentioned overpressure is always making sure that we don't have an overpressure coming in to the user systems from the engines. And so we have an overpressure bleed valve that's going to close automatically when that engine bleed air exceeds a certain set pressure, right? Because we don't want to, again, have too much going to the user systems throughout the aircraft. It's not a good thing. So your OPV, okay, short for overpressure bleed valve or overpressure valve, that one's also butterfly style, all right, and you know that's going to be regulating that. It's going to be regulating. It's going to be watching for that, because you know we don't want to have it go past a certain amount. So what happens, okay, when you have the upstream pressure that increases and goes up to 75 psig, then that valve's going to close. Okay, and what that's obviously doing is going to decrease the airflow, which is going to reduce that pressure. And then what at 85 is another key, psig, if you will, because reaching it up to 75 is going to close the valve. Then at 85 upstream pressure, okay, so at 85 psi upstream pressure, the OPV is going to fully close. And then it opens again when the upstream pressure decreases. So when it decreases to around 35, that, you know, that's when it's going to open. And of course, these valves, a lot of them have safety devices, so just be aware that's just a fact. Okay. All right, and as far as location for the overpressure bleed valve, that is also in the engine pylon, and that's accessed by opening the fan cowl doors to get access to that if you need to. Okay. All right, so that gives you an idea with the engine-related components, with the precooler exchanger and the fan air valve, thermostat, you know, all that's related to the precooler exchanger. You know, then we have the transducers that I mentioned as well, and of course your pressure regulating valve. Okay, so you have your pressure regulating valve, and also your high pressure bleed valve, okay, and the solenoid, and of course your overpressure. Okay, so now I want to talk about the components that are related to the APU. That was for engines, for the supply coming from engines. But what about the APU bleed air? Okay, so what components do we have here related to that? We've got what's called the load valve, and we also have a check valve. So load valve and check valve. Your load valve is going to either allow or not the bleed airflow from the APU to the systems. Okay, that valve is kind of an off-on situation because it doesn't control how much airflow is going through. It's just either going to stop it or allow it, one of the two. Okay, it's just a shut-off valve is all that is. Okay, so what happens here? Okay, this bleed load valve, okay, it's a position indicator switch, okay, and it's going to be transmitting signals to the ECB for that, so that it can get that information about the valve position. Because remember, we're talking about valve position here as far as being able to monitor, so valve position, temperature and pressure, right? So here we have this with the information signals getting sent to the ECB for, about valve position here with this particular one with load valve. So on the actual push button switch, you're going to have the APU bleed, okay, and that is where, you know, you get the APU bleed signal. Okay, that's all from the 30 VU panel in the, you know, in the flight compartment. All right. Okay, so the start sequence, this is kind of the beginning of what happens here and involving the load valve. But you've got the start sequence that happens with the APU. Of course, this is standard because if you know, read or know about the other ones, the APU's needing that 95% speed. Okay, so obviously when it reaches that and goes beyond, then we're good to go. You've got the APU actually doing some work. Okay, so, and then of course you've got that's, you know, that's the load valve, like I explained, you know, as far as what it does. And then you've got, you know, what happens here with the load valve, okay, is if when you have that APU available, okay, you can push the APU bleed push button. Okay, this is there's an APU bleed push button switch. It's on the 25 VU. Okay, there's APU. There's one on the 5 HV on the overhead 30 VU, and then you have one on the 25 VU to start that APU bleed air supply. Okay, that's on the 25 VU. So when you push that button, kind of to start it, you're going to have the blue. It's going to be a blue color on legend that's going to come on. That button's going to send a signal to the BMC, okay, and then what happens? That's the brains of the operation, right? The BMC's then going to send a signal. It's going to send a basically for like instructions to do a test of all the sensing elements, okay, on the bleed air duct, because it wants to make sure everything's working right. Okay, also to the bleed air ducts, okay, to the sensing elements there, because remember that's where you have the location of those sensing elements. So, you know, so everything basically is doing a little test. Okay, and if everything's good, then it's going to tell the APU bleed valve, the load valve, to just go ahead and open. Okay, so it's going to do a system check first before allowing the load valve to open. Just bottom line, that's what I'm trying to say. Okay, which is pretty cool. All right, and of course you can see the different position or different, well, the positions of the different parts to the load valve. With your pneumatic actuator, you've got your receptacle, your electrical receptacle, you got a visual position indicator, you also have position indicator switch, you got a test port, right? And of course your butterfly in there, so you got all that. Okay. Okay, and just so you know where it's located, the load valve is going to be obviously near the APU. So this APU bleed load valve is actually on the right side forward end of the APU. Okay, so if you are ever asked on a test, where's the APU bleed load valve located, that's where it's at. It's on the right side forward end of the APU. That is the answer. Okay. Alright, so we got one more component under the APU, and that would be a bleed check valve. And that's going to be installed in the duct, and that's going to be protecting the APU when a different source is supplying that bleed air from a higher source. Okay, so it's a protective thing. Okay, we know that check valves are. In this case in particular, just to mention the components here, and of course I've mentioned the components with the load valve, but here you've got the shaft spring flaps in their housing, obviously. Okay, so bleed check valve, where is this located? This is located at the duct exit from the fuselage skin below the right wing root. Okay, that's under panel, a certain panel there. Just refer to your maintenance manual. Okay, I don't want to be mentioning in case you're, I don't know which one you're going to be working on, so as far as whether it's the 19 or 20 or 21, so just be mindful of that just in case there's any little difference in configuration. But that check valve is at the duct exit from the fuselage send below a right wing root. Okay, and it has been mentioned okay, from sources, from my sources, from our sources, that you know, it has happened that maintenance technicians have forgotten certain pieces, and so they didn't assemble something, you know, reassemble, should say, put back together correctly. So those are things that can be missed visually sometimes, and maybe that's happened to you. So you know, be aware of that when you go through, do your own inspection before it actually gets inspected by the inspector, because you know, we don't want to have anything, obviously have anything negative come as a result of that negligence. Okay. And kind of check too, right when you're, like, before you're gonna actually do repair, check what's there first, you know, like what's given in your situation. I'm talking about, you know, what you're trying to replace, and just take a note of that, because again, there maybe the person before you or whatever, you know, something maybe wasn't right, and so you're actually, you know, checking that out, you're looking at it and seeing. So just kind of a heads up on that. Okay, and this gives you an idea, I mean, just of the check valve, type of the APU bleed check valve. Really nothing much to that one. Okay, all right, so if you were given or asked, okay, APU bleed air related components, what would those be? Okay, I just mentioned the two. There's the load valve and there's the check valve. Okay, load valve will not open unless there's a system check first, to make sure that, you know, everything's good before letting in that air into the user systems, into the ducts. Okay, so now let's move on to our last part, I should say section of talking about components, and that would be the cross bleed system. So your cross bleed system's connecting the left and the right sides, right? It's connecting those ducts from each side. And then you have the cross bleed valve. Okay, that's your component related to this cross bleed system, that then can isolate, you know, those two sides, the left and the right. All right, so the APU bleed air duct is going to connect the APU, okay, because the APU bleed air duct can connects the APU to the cross bleed duct. Okay, and the duct itself is in the unpressurized area, and it's connecting the left and the right bleed air systems. Okay, so might be a test question just about, you know, whether that's a pressurized area or unpressurized. It's in an unpressurized area. Okay, and then there's, of course, you have that cross bleed valve, and that's going to control the bleed air supply that's going to the left and the right bleed air systems. Okay, so what happens when the PRV, I'm talking about the pressure reducing valves, all right, and I know don't let this confuse you, you probably already know, but a lot of these acronyms, some of them are actually stand for two different things, so I think you may already know that. So just know here, pressure reducing can also stand for pressure regulating, but at any rate, when the engine PRVs close, then the cross bleed valves open, okay, or the cross bleed valve opens, and that's going to open automatically when the APU is the one supplying that bleed air, because when the other one's closed, we're talking about engines are no longer there to provide that, then it's going to be coming from another source. In this particular case, I'm talking about the APU, right? Okay, so there's a selector switch for this cross bleed valve, and in its regular position, okay, its normal position, if you will, it's going to be in the auto position. And so you have this auto position. Remember, a switch is electrical, so you're going to have a coil in there that the coil of this cross bleed valve that gets connected to one of the buses. Okay. All right, so what happens when the pilot pushes on the APU? Are you doing this on ground for maintenance, and you're pushing the APU bleed push button switch? Okay, you're going to push it to the on position. Then what happens? That's going to trigger a signal to be sent, okay, for the PMCs to send a ground signal to the ground bleed auto control relay. And it's going to do it if you have the APU bleed load valve in its full open position. Okay. And of course you have okay, then you also have on the bleed page, okay, of the system display, you're going to have a green cross bleed valve symbol. So that means it's in the open position. Okay, so there's a symbol for cross bleed that's going to be showing in the open position when it's in the color green. Okay, it'll show up in green. Okay, so and then you have this relay. I know I didn't fully say that, but it's actually an auto control relay that's giving that electrical power to the valve. Okay, the valve's electrical, right? So the relay is just going to monitor that valve when it's in its full open position. Okay, so it's just monitoring is all I'm trying to say. Then you also have a manual control of the selector switch. Just know that you do. One of them is in a certain position or switch position of 5 HV, the other one's 3 HV. Do refer to your maintenance manual. That might be a different, you know, a little slightly different. And just know that there's manual control besides automatic control. Okay. Okay, so when we're talking about the manual control for a second, you know, when are you going to do this? Okay, you would put this cross bleed valve selector switch in an open position at the start of an engine with bleed air from an engine on the other wing. Okay, this is not during flight, by the way. Okay, or there's an engine bleed air failure. Okay, just a couple of examples I'm giving. Okay, and there's kind of a cross bleed fit system layout, so you can get a feel for, you know, how that comes together. Okay, and you know, like a lot of valves, they have motors, you know, or 1 or 2 motors. This one has 2, just so you know. And the location of this cross bleed valve is in the forward right air conditioning compartment. Okay, so where is the cross bleed valve located? It is in the forward right air conditioning compartment. All right. And I'm not going to go into the basics of the valve. The valve is just open and close. One motor opens it, one closes it, or one opens it, one closes it. Okay, and it gives you kind of a visual on where what identification essentially of the different parts to the valve, with where the label is and valve body, obviously the flange, and your actuator motors. Okay. So it gives you an idea when we talk about the cross bleed valve, cross bleed system. You know, what does it do? You can isolate the left and right. It connects. Okay, the cross bleed system is enabling the ducts to be connected or ducts connecting so that you can have basically pulling from the left and the right, supplies. But if there needs to be an isolation of one side over another, then the cross bleed valve can do that. That is its job, is to do that. Okay, so along with that, you have a cross bleed valve. Okay, so that I just broke down the components, locations, like where are they located. I just broke them out. Just think about it in a broad stroke of there's components related to the engine bleed air system or supply, and then you have also the components having to do with the APU bleed air supply, and then lastly you have the cross bleed system, in which case we have a cross bleed valve. Okay, so think about that like in 3 different compartments, if you will, like in your mind, and that way you can just break. It makes it a little easier to say, okay, here are the components for this one, and it's having to do with APU or or having to do with the engines. Okay, so that pretty much sums it up for session 2. We are going to go over some knowledge checks. I am not going to, again, say or go over every single test question, because these knowledge checks, or practice questions, or you're more than likely you're going to see most of them on the test, I should say. But if you actually know some other things and you don't find it on the test, and by gosh, wow, isn't that great? You've gotten more knowledge than you were tested on. That's great, because it's not about just what's produced on the test, but if you have extra knowledge, that's great. From that. So, all right, we'll go ahead and close up. If you have any questions for our instructors on staff, definitely email us, and we'd be more than happy to help you through anything that that you have questions about. Okay, thank you. These are the knowledge checks for the Airbus A320 topic on pneumatics. I'm going to break it up, session 1 and session 2. Session 1, control and monitoring the bleed air system. Let's start with question number 1. Go ahead and follow on your handout. Number 1, what is the primary source of compressed air for the aircraft in flight? Is it auxiliary power unit or aircraft engines? The answer is aircraft engines. Number 2, some of the aircraft systems that the pneumatic system supplies are: number 1, nacelle anti-ice valve, wing ice protection system, pressurized water system, and the engine starting system? Or is it the second choice, nacelle anti-ice valve, wing ice protection, flight controls, and air conditioning system? The answer is number 1, first choice. Number 3, what automatically controls the pneumatic system? Is it A, first question, first answer, pneumatic control boxes, or B, second question, or second answer, bleed air monitoring computers? Okay, it's the second choice, bleed air monitoring computers. Number 4, what is the function of the overheat detection? Is it monitors the bleed air temperature, or is it monitors bleed air ducts for leaks and bursts? The answer is the second choice. Number 5, what triggers the BMCs to send a warning via the SDACs to the Ecam? Is it A, overpressure, low pressure, or when the temperature in the bleed air ducts exceeds 300 degrees Fahrenheit? That answer is the first choice. All right, session 2, number 6. What is the location of most of the pneumatic components? Is it in the accessory gearbox or in the nacelle and pylon of each engine? The second choice. Number 7. What component controls the air temperature downstream of the system? Is it the bleed air Precooler exchanger? By the way, what component meant cools? Okay, cools the air temperature. Okay, there's a bleed air Precooler exchanger, or is it the fan air valve? Okay, it's gonna be the exchanger. Number 8, during low thrust operation, okay, low thrust, what component prevents reverse airflow from 9th stage high pressure air that goes into the pneumatic supply ducts? Is it the intermediate pressure valve or the bleed air pressure regulating valve? That's going to be A, the first choice, intermediate pressure valve. Number 9, where is the intermediate pressure valve located? Is it adjacent to the oil tank or in the engine compartment? That's letter B, that's the second choice. Number 10, our final question, where is the intermediate pressure check valve located? Is it in the pneumatic duct leading from the 9th stage high pressure compressor, okay, HP compressor, or is it in the pneumatic duct leading from the 5th stage HP compressor? Okay, that's coming from 5th stage. All right, so now you've got some idea on what questions will be asked on the pneumatics topic when you get to that. Okay, and of course, if you have any questions, you can email us, or you need clarification, please reach out to us, and we'll be happy to help out.